In this movie, I demonstrate how to create a die in OrbitIO from nothing more than an existing package and a left technology file. No gate level netlist for the die is needed. This is the package-driven, start-from-nothing die creation flow. I begin with a package BGA, which is created using techniques shown in other OrbitIO movies. It has a ball array with personalities assigned and a netlist with the nets assigned to balls grouped in interfaces. I will load some existing left technology files for the die I'm about to create. These left files give me the layer stackup and the bump macro definitions that I will use. As I create the die, I select the substrate that was created when I loaded the left in the previous step. I then specify the die size and create the die. I move the die into the package hierarchy, then place it in the center of the package face down, as this is a flip chip design. I will create 4 different bump patterns, beginning with the peripheral bump rings. I fast forward through the parameter settings for each of these bump patterns. I don't need the bumps at the bottom edge, so I will delete those. The next 2 bump patterns are created using the ratio-driven functionality. I specify the number of signal pins I need, then the ratio of signal to power and ground. The bumps are created and assigned signal, power, and ground personalities based on the specified ratio. In this example, the yellow pins are signals and red and blue pins are power and ground. Note that no nets have been assigned yet. I move the pins, then I use pin swapping to rearrange the personalities as needed. The left technology file defined the manufacturing grid as 0.005 microns, and as I move the pins around, they are snapped to this grid. I'll repeat this process for the 3rd pattern of bumps. Notice each pattern of bumps can use a different bump macro. It can have different pin pitches and different parameters and different ratio settings. It's very flexible in creating a variety of patterns that may be needed in the die. I finish the bump creation with the core bump pattern for an array of power and ground nets. I select the pins in the core array and add the pattern specifying the net names of VDD and VSS. Note that this command not only adds the power and ground personalities, but it also creates the nets and attaches them to the pins in alternating horizontal rows. Note here that I have also created signal, power, and ground personalities on the peripheral bumps as shown here. Now that the bumps are created and signal, power, and ground personalities are in place, I use bundles to assign nets from the package to the die. I select the bundles by interface floor plans on the package and assign by personality to the die. This operation keeps track of the order of the nets as they enter the bundle from the package and assigns nets to the die bumps in the same order. Not only does this optimally assign nets to the die pins, it also adds the nets in the die so that they can be sent to the IC design tool to continue implementation there. After bundling, the pin assignments may be further optimized through the use of the automatic die and package breakout utility. By defining the breakouts on the die and the package, you can better control how the package is routed in SIP layout. I do not show the breakout routing step in this movie, but if you're interested in seeing how it works, please refer to the other YouTube OrbitIO movies that show this operation in detail. Now that the die is created, with bump patterns and signal, power, and ground nets assigned optimally for this package, I will export a Verilog netlist and a def floor plan of the die. I switch over to the Cadence Innovus implementation system for IC implementation. I load the original left files and the Verilog netlist to initialize the design. I then load the def floor plan. This brings the pin pattern and net list that was created in OrbitIO into Innovus for the die, place, and route phase. If you would like to learn more about how OrbitIO can streamline your chip package board design flows, please contact your Cadence sales representative.